Hi viewers, welcome to the Junior Astrophysicist, and in this video we're going to be looking at understanding waves. And in understanding waves, we're going to be firstly focusing on the types of waves, which in basic are the sine waves and the cosine waves. And along with that, we'll also see the parts of the wave and the equations we use in waves. So let's begin now. So yes, these are the topics for today's video. Let's begin with water sine waves. Sine waves are waves with very smooth oscillations, and they have constant amplitude. Their sine wave is formed from the sine function in trigonometry, and the waveform in which the amplitude is always proportional to the sine of the displacement angle, which means that the displacement angle of the graph, the sine value of it, is always proportional to the amplitude of the curve. And the final point, all waves can be made by adding up sine waves. Let's look at an example or a diagram of a sine wave to have a better understanding on this topic. So as you can see, this is a sine wave with a very constant amplitude, and it starts at point 0 on a positive quadrant, and it's with respect to time. That is sine wave. Now let's see what are cosine waves. Cosine waves are waves which are very, very similar to the sine waves. But there's always the difference of why you change the name. It's because the cosine wave begins 1/4 cycle earlier or 90-degree phase difference than the sine. So it begins 90-degree or 1/4 cycle earlier or before the sine wave. So we can take a look at the cosine. As we just saw, the sine wave begins at point 0, and the cosine wave begins at 1/4 cycle or 90-degree phase difference before sine wave. It is before 0 on a negative quadrant. This is a comparison graph of both sine wave and cosine wave. This graph begins at point 0, so you can see that the cosine wave is half, and the sine wave is a full wave. It begins at the perfect point, but cosine wave is already half of it's gone. So the red color is the cosine wave, and the blue color is the sine wave. The next topic is labeling waves. So the top part of the wave is what we call the crest, and the bottom part is what we call the trough. The distance between two waves or two crests is what we call the wavelength, and the amplitude is the distance between or the distance of your curve. May it be on the negative, like for the trough, it can be for the crest, but it's only the height of the curve. Let's look in detail about all these stuff. Wavelength and amplitude. As we just saw, wavelength is the difference of distance between two crests, and it's represented by the Greek symbol lambda, as you can see in the screen. So that's how you use it in the equations. You represent it with the Greek symbol lambda. And amplitude is the height of the wave. At the next topic, frequency and wave number. Frequency is the number of waves produced in a very fixed period of time, and is represented as f in the equations. But wave number is the number of waves produced. We don't have a certain time. We don't have fixed time. It can just be the number of waves. So it's represented in the equations as k. The next thing we're going to look at is Planck's constant. So this Planck's constant is a certain constant value which relates the energy of a photon to the frequency. We shall get to that equation soon, but for now, let's just look at some of our stuff on this. Other equations and energy. Now, this is the Planck's constant. 6.6260704 is 10 to the power minus 34 m² kilogram per second. This is the constant, and it's represented in the equations as h. Next thing are the equations. So the first equation is where we're going to see in the de Broglie wave. De Broglie wave is the wave of elementary particles like electrons. So while studying quantum physics, we discussed mostly about electrons and the wave function of electrons. So we only use the wavelength formula and de Broglie relations while calculating waves for electrons. So the formula for that is wavelength is equal to Planck's constant divided by momentum of wave. So wavelength is represented by lambda, Planck's constant is represented by h, and momentum is represented by p. So lambda is equal to h by p. Next, matter wave. For matter wave, the wavelength is equal to speed of wave by frequency, or lambda is equal to Cm. We're not going to be discussing about matter waves because we're studying only on elementary particles or electrons. So we go into the equations based on the de Broglie relations. Now, the first equation is the momentum is equal to Planck's constant divided by the wavelength, or P is equal to h by lambda. You use it to calculate the momentum. And the energy of a photon, this is equal to Planck's constant in frequency. As we saw, what was Planck's constant? And the definition was given clearly that Planck's constant relates the energy of a photon to its frequency. This is the formula we use for that, E is equal to h. And the final formula is wave number is equal to 2 pi divided by wavelength, or k is equal to 2 pi divided by lambda. So I'm sure you would have learned about waves, sine waves, cosine waves, particle wave, and the equation we used while studying electron wave functions and quantum physics. So don't forget to drop a like, share, and subscribe to the Junior Astrophysicist. See you guys. Bye. After learning